Hello, students. This is a big topic for the final. We're continuing to talk about inscribed angles. And we found out that there's this formula we can use, which is that the inscribed angle is half the measure of the arc. Half the measure of which arc? Well, this is the inscribed angle. The vertex is on the circle. And the arc is where the angle crosses through the circle. And what we know is that this angle, when it gets all the way to the edge of the circle, it becomes half. If it's at the center, it's still 80, but if we pull it to the edge of the circle, it's half. So the measure of that angle is 40 degrees at the edge. On the arc part of it, it's 80, but when it gets into the pulled to the edge of or onto the circle, it's 40. So half. This problem I've done before in the previous video, and I messed it up because I got confused with my basic math. I'm going to do it a different way. And this way is different than the way I did it in class. So if you're watching the video, you might get something out of it. So first, I'm going to start with the measure of angle D. And the measure of angle D is going to be half the intercepted arc. That's arc EBC. All right, and I'm going to use a calculator this time so I don't mess up my math. So 90 and 63 together is 153. So I'm going to do 153 divided by 2, and that's going to tell me that the measure of angle D is 76.5. Okay, this time, instead of dealing with more of these arcs, now I'm going to use the fact that a circle is 360. And the opposite angles inside the quadrilateral cut the circle. I'm going to use blue right here. This angle right here, angle C, cuts through the circle at point B and point D. Okay, now I don't know the measure of this arc at the moment, but I do know that it's the other part of the circle from here, because angle E also cuts through the circle at B and C. So this happens to be 63. Whatever this is, the rest of it is, I'm not explaining this super well. The rest of it, all the way around the circle is 360. So this part of the circle we take off half of, and this part of the circle we take half of. So a shortcut, easy trick to do this problem is that these two, the opposite angles, add up to 180. So I can do 180 minus 63, and that's going to tell me this is 117. Okay. So these two angles here are supplementary. They add up to 180. Okay, same is true for these two. So a shortcut, fast way to do this problem is to say, what do I have to add with 176 to get this angle? What do I have to add with 76.5 to get to 180? So I'm going to do 180 minus 76.5. And the answer is minus 76.5. Is 103.5. Another way to check this is add up all four of these angles and see if they equal 360. That's another way to check. All right, this is another quick piece that you need to be aware of. The measure of an angle formed by a tangent and a chord. You guys remember what tangent is? This is a tangent. It hits the circle at exactly 1 point. I had a little bomb emoji that I was using for that. Here's a tangent and a chord. A chord has both, it's a line segment with both endpoints on the circle. So this is a chord. And I can name some of these points. I can name the tangent line R, and maybe S, and maybe T. So we have tangent line SR, and we have a chord ST. And this says that the measure of the angle formed by the tangent, so the measure of the angle, RST, is equal to half the measure of the intercepted arc. So where's the intercepted arc here? This is the angle that I'm talking about. Notice it's not completely in the circle. Its vertex is on the circle, but part of it's out here and part of it's, you don't focus on that part though. This is the angle we're trying to find the measure of. Where does that angle hit the circle? Well, it hits the circle at 2 points. It hits it here and it hits it here. So the intercepted arc is arc ST. So if I said that this was 118, is that right? Does this angle look like 118? Looks more like I guess it looks like it's a little obtuse. Okay, let me undo that. Okay, we'll call it 118. And so all I would have to do is I would have to take half the measure, half of 118. If I just made up that number there, and that's going to be half of 118. 118 divided by 2. 59 degrees. Does that look reasonable? Yeah, not bad. Okay, so let's do this one. Segment BD, line segment BD, is tangent to circle A at point D. So this is the point of tangency. We know that the measure of arc DFE is 122 degrees. That makes sense. It's a little bit less than 180. And we want to know the measure of angle BDE. Well, we just learned that it's going to be half. So all I have to do is 122 divided by 2, which is 61. Here's a summary. If you're dealing with an inscribed angle, like you will on the final, what you need to know is that the measure of the angle is half the measure of the arc. The measure of the angle is half the measure of the arc. The measure of the angle is half the measure of the arc. The measure of the angle is half the measure of the arc. Always. If the vertex is on the circle, it is half the intercepted arc. Half. All right, now let's do some problems. I'm going to choose one of these and put them on the final. I put them as the homework assignment. I'm allowing you time in class to work with your classmates on this. So let's see how these work. I think I'm going to use a little bigger pencil here. So if the measure of arc DG, here it is 45.6. How nice is that? What are the measures of angle E? Let's just do E first. So here is the inscribed angle E. It is this angle that I'm trying to find. And we just learned that it is half. Measure of angle E is half the intercepted arc. Its intercepted arc is DG. And we know what the measure of arc DG is. It's 45.6. So I'm going to do 45.6 divided by 2. 22.8. So I'll put that in a box. Measure of angle E is 22.8. I can put that on the figure. It's kind of small, so I'll put a little arrow, 22.8 degrees. All right, and we have to find the measure of angle F. So let's change colors. Here is angle F right here, where that's the vertex. So the angle that we're talking about is this angle. Interesting, isn't it? Where is that angle hitting? Well, the measure of angle F is also half of the measure of the intercepted arc, which is DG. Now I don't need to do this math. I know that the measure of angle F is also going to be 22.8. Okay, so that's kind of an interesting thought, that because they have the same, because they cross the circle at the same 2 points, these angles are going to be congruent. So bonus, angle E is congruent to angle F. Why? They have the same intercepted arc. Let's do some more. Ooh, this one's fun. All right, we got measure of arc ABC. ABC is 184. Okay, I worked with a lot of different students on this problem. I'm going to show you the most straightforward way to think about it. These can get confusing if you are, they take practice, they take effort. So if you're feeling frustrated, and that probably means you're doing it right. You're thinking it through, you're struggling with it, so that's good. Half of 184 is going to give me which angle here? This one. So I know the measure of arc ABC is 184. That means this is 92. Now, instead of going and getting this next piece of information, I'm going to ignore this for a little bit. I'm just not going to worry about that for now. I'm going to just focus on here and see if I can find out anything else. And what I can find out with just this information is I can find the rest of the circle. I don't know how much DC is. I don't know how much AD is, but I know that the rest of the way around, we had 184 this part. The rest of the way around is going to be 360 minus that 184. Okay, so I learned my lesson. I have a calculator next to me now. 360 minus 184 is 176. Okay, so this part's 176, this part's 184. And if I want now, because now I have this arc, I can find this angle, because the angle B is crossing through the arc there. So if I want this angle, I'm going to take half of 176. Half of 176 is 88. All right, if you watch the beginning of this video, you also would remember that if I add these two together, they're going to be supplementary. They're going to make 180 when I add them together. You can check it. What's 88 plus 92? Yeah, the whole circle is 360. If you take half of this part and you take half of this part, it's going to be, that's going to have to add up to 180. Okay, I'm going to now get rid of these markings and get ready to do the other part of it. I'll leave the angles that I found in there. But what I'm going to do now is go back and use this piece of information. So now I'm going to ignore this for a second. And I know that the measure of arc BCD, wow, that's almost all the way around the circle, is 242 degrees. Okay, so what angle do we know? Or what angle is that going to give us? Well, all the way around here is 242. And this angle here is crossing the circle at B and D. So this angle, angle A, is the inscribed angle for this arc. So this is going to be 121. What's 242 divided by 2? 121. Okay, now I could just subtract from 180 to get this number, or I can think about the circle. One more time, the whole circle is 360, and I already know 242 degrees of it. So this leftover arc, I don't know the AD or AB, but I know the leftover arc is 360 minus 242, which is 118. And what is half of 118? I randomly included that. My subconscious brain probably put that number in because I've been working on these problems. Okay, that's it. Let's do more. These are on the final, probably these exact same problems. What do we know on this one? We know the measure of arc RST. RST is 164 degrees. What is the measure of angle RVT? From R to V to T. Oh, that one's too easy. Do you see it? There's all this extra stuff in here that you don't need. My brain does this, you guys. My brain says, ew, I don't need you. You're confusing me. You're confusing me. Go away. I don't need you. I don't need you either. I don't need you. Right? And then I'm left with a really simple problem. I have the measure of the arc and I want the measure of the inscribed angle. And that is simply this. So my brain gets rid of all the extra stuff in the figure that was trying to confuse me. And I just do half of 164. Half of 160 is 80. Half of 4 is 2. So this is 82 degrees. If you want to show work, you could do it this way. For the final, I'm going to ask you to talk it out and explain how you know. But if you are able to quickly tell me the formula and what you're doing, that's also a good thing. So half of 164, and just to be on the safe side, I'm going to do that on a calculator. It's 82. Okay. Measure of angle RVT. This is a way you could show work. That one's not so bad. Let's see what's happening with this one. My goodness. Given that line BD, where the heck is that? Here, okay, is tangent, okay, to circle P at point C. Right, it looks like a tangent line. They're telling me it's a tangent line. That's good. If the measure of arc AC, so let's go find that. Arc AC is right in here. I'm going to put the 88 right there. What is the measure of angle ACB? So there, I think I'll change colors. So this is what I was given, and I'm going to need the measure of angle ACB. This is the angle that I'm looking for. Well, that sounds like something I just learned about. Okay, again, this figure has a lot too much going on. So all this stuff, my brain just fades away. Okay, and I focus in on this part of the figure. And the relationship here is I have an angle, happens to be yellow right now, whose vertex is on the circle. And what I want is and I have the intercepted arc, so all I have to do is take half. So the answer is 44. This should work. You could say the measure of angle ACB is half the measure of the intersected arc, which is AC. You could say the measure of angle ACB is half of 88, which is 44. You want to practice your good syntax, get ready for Algebra 2. This would be a good way to practice. All right, moving right along, halfway there. Ooh, I like these more open-ended. Find all the missing measures and things that you can find. And what I didn't have in here is that we're going to assume this is tangent, which you can't always assume, but in this situation you can. So let's start. My brain just went to here first. If this is 50, can you go the other way? Can you tell me how big that is? I think I'm going to make this picture bigger. So let's just zoom way in because I'm not going to show any of the formulas. I'm just going to work the circle figure. So that's 50. What is the arc? Can you go backwards? The arc is going to be 100. Does that make sense to you? Because it's double. So if I'm keeping track of things that I figured out, I found the measure of arc xz is 100. What else can we find out? Well, my brain's out here, 100. I see 196. Can I figure out this part out? No. Let's change colors. Let's use green. How am I going to find out the measure of that green arc? Well, 100 and 196 is 296, and I have to get all the way to 360. So my math problem is going to be 360 minus 296. 360 minus 296, 64. Okay. I'm just going to double check 64 plus 196 plus 100 is 360. Good. Okay. So I found out the measure of arc Vx is 64 degrees. If I know that arc, what's the inscribed angle that goes with it? Well, it's this one. So how big is this angle? 32, because this angle is 32. The measure of angle VXW is 32 degrees because it's half. What else do you think we can find? Oh, what about the big one in the middle? There's two ways to find this. Do you know both ways? Let's use yellow. There's two ways to find that angle. Okay. Well, it's kind of interesting to think about which way you would do it. Because we're learning about inscribed angles, I'm going to do this way, which is that the measure of angle ZXV is half of 196. So I'm going to do 196 divided by 2. That's 98. Does that look like a little bit bigger than a right angle? Yeah. What's the other way to do the problem? The other way to do the problem is say that 50 plus 32 plus something has to make a straight line. So we can check it by adding 50 plus 98 plus 32. It does equal 180, so I'm pretty sure it's right. I checked it because these three angles together make 180. I think we did it. I don't see any other arcs or angles that we can figure out here. So go us. Let's do more. Find the measure of all the missing arcs and angles that you can. Awesome. Let's do it. So this one's kind of interesting. I like the letter J. I'm randomly going to start there. Let's see if we can find this one. Do we know its intercepted arc? Yeah, it's going to be 120 plus 46. And then divided by 2. So that's 166 divided by 2 is 83. So measure of angle J is 83 degrees. There's only one angle J in the figure, so I don't have to use all three letters. Okay, what else can we do? Work the figure. I'll leave the 83 in there, but I'm going to get rid of these. Let's go put the 83 back. Okay. Now I could just use the trick, which is these two have to be 180 and these two have to be 180. Or I could make it hard on myself and I could try to find the length of the measure of arc KJ. That would be kind of fun to try to find. And I know that that is going to be, let's see, if I think I'm going to get in trouble starting that way. Let me start with this way. I kind of want to figure out KJ here. I think that would be fun. So let's do the measure of angle M is going to be half the measure of the intercepted arc, which is going to be LJ. So I know that 49, because I already knew that the measure of angle M was 49, is going to be half of, arc addition postulate. It's going to be half of 46 plus some number. I think I just tried to make this really hard, but I think this is fun. Let's try it. So I think the first thing I'll do is just double it. 49 times 2. That's 98. What that means in the picture is that from here to here is 98. Right? That's the measure of arc LJ. If I want to find X, then all I'm going to do is take away the 46. So in algebra, this would look like taking 46 off both sides. Some people see it really quickly visually, and other people like to see the algebra. So I'm going to do 98 minus 46. 98 minus 46. And that's 52. And the point of this whole, all this stuff is, can you engage with the figure? Can you work it out? Can you think it through? And now I know that X is 52. That was kind of fun. All right, what else can we find? We know this, don't we? We know the measure. How would I find the rest of it? 52, 40, 46, 120, and whatever's left over. Do you think this is going to be more than 180 or less than 180? I don't know. Okay, I'm just going to do 360 minus 120 minus 98 is 142. 42. If you're not sure, add up all the numbers around. It's supposed to get to 360. And now let's find the measure of angle L. How about? Ooh, that's kind of fun. There's so many different ways to do this. The way that I'm doing it now is not the right way. Okay? The right way is, can you look at the figure and engage with it and get it to work for you? Okay. 142 and 52 together is 194. 194 divided by 2 is 97. If I add 97 degrees with 83 degrees, it equals 180. So that I know that those two are right. How about this last piece? I've got all the arcs so far, and I need one more missing angle. Yeah, let's use yellow. I need to find the measure of angle K. And K is going to hit the circle here and here. Ooh. So I need half of 120 plus 142. That's going to be 242. Half of 242 is 121. What's 121 plus 49? I did something wrong. 242. Uh-oh. Help me. 142 plus 120. Oh, 262. Thank goodness. Okay, 262 divided by 2 is 131. And 131 plus 49, aha, it is 180. See, I did it. Okay, I solved everything. Awesome. Let's do more. I like these. These are going to be on the final because they're cool. I want to hear you talk it out. I want you to do what I'm doing. Practice. Given line DF is tangent to the circle at point to circle Q, and the point of tangency is E. All of these words are basically just telling you that this line is exactly hitting the circle only at one point. I want to find the missing measures of arcs and everything that I can. So let's keep moving here. That's 72. Whoa. And so the first thing I'm going to do, I'm going to start with that 72 and go for it. What is 72 times 2? 72 times 2 is 144. Okay, so I got 144 here. Now I'm going to go out to 106. This time I think that I will see this inscribed angle right here, and I'll do half. Okay, what's half of the intercepted arc? Half 106 is 53. Because half of 100 is 50, half of 6 is 3. So 53. Ooh, that's a degree symbol. Oh no, that looks like a 0. Make it smaller. Put one on there too. Okay, let's continue around the circle. I have a couple choices. How about this time I do 180 minus 72 minus 53. Now I'm just going to say, hey, these three make a straight line. So I'm going to do 180 minus 72 minus 53. So this is a 55-degree angle. Check it, 55 plus 53 plus 72, 180. So this missing arc around the edge of the circle is twice that. So 55 times 2 is 110. Now, how can I know if I'm right? Well, I can add 110, 106, and 144, and it better add up to, I'm going to do a little check over here. I'm going to do 110, we're going to do 106, and we're going to do 144. If I'm right, it's going to add up to 110 plus 106 plus 144. Hey, 360. That's a good thing, because that's all the way around a circle. It has to be 360. Any other angles we can try to find? Any other arcs? I think we're good. Last one. Play with this figure. See what you can tell me. Work it. Ooh, I'm going to make it big so I can write on it. Let's see what we can figure out. My brain started here. There's no right or wrong place to start this problem. Okay, but if this is 106, then out here is 200 and, ooh, that part in there is a little tricky. 212. I might write it out. Measure of arc, RST is 212. Okay, how about the measure of arc ST? So how about this part in here? For that, I'm going to do 212 minus 86. 212 minus 86. 12 minus 86. 126. Okay, so the measure of arc ST is 100. It's minor arc. It's less than 180. Anything else we can find? Oh my goodness, so much going on in this figure. I think I'll erase some of it. Well, you kind of simplify your thinking. So let's go to another spot. I'm going to leave those numbers there. Anyone think what they want to do next? Maybe angle P, that looks like fun. For some reason, my brain is drawn over here. I'm sure a graphic designer would not know why that's happening. You see it? Here's the intercepted arc. So how much is this angle? Good. It's half, right? You starting to see it? Hope so. So that's 41. We got 120. How about, where can we go next? 126. How about over here? It's yellow. You see it? Where's angle SRT hitting the circle? At 126. So this angle all the way out to the edge is going to be half. Half of 126, half of 12 is, or half of 120 is 60, and half of 6 is 3. So that's that. Ooh, it's so fun. What do you guys see? Ooh, this is a triangle, isn't it? Could we find this one just by looking at the missing triangle measures? We haven't done that on one yet. So I'm going to do this one on my calculator. I'm doing 180 minus 106 minus 41. And that's going to tell me the missing angle is 33. How did I do that? I used the triangle. Inside a triangle is how much? 180. Okay, since I just saw that, I'm gonna take this 33-degree angle, and where is that gonna be on the outside of the circle? These are so fun. If it's 33 at the edge of the circle, by the time it gets out to the arc, it's double, 66. Kind of cool. Ooh, I can find this one now, because I have the rest of the circle. So I could do 360 minus everything. I wonder if there's another way to do that one. Let's do it that way. I like subtracting, so I'm going to do 360 minus 66 minus 82 minus 86 minus 126. Let's see if I did that right. 360 minus 66 minus 82 minus 86 minus 126 is, uh-oh, that's a 0. Oh, did the 126 actually go to P? The 126 actually went to point P. Okay, so I've made a mistake. Darn it. Darn, darn, darn. ST is not 126. My goodness. SP is 126. That means this one was wrong. Wah, wah, wah. Let's see if I can find my mistake. See, I got 0 when I did that math, and then I knew, uh-oh, that's not right. So that was SP. That was 126. So I know that this angle is that 63. Okay. And I don't know this one now. So let's see if we can keep working it. But that was a incorrect assumption there. There's a lot of numbers. When it's late at night or early in the morning, you can get mixed up in these. All right, now what? Got the 120, 212, 126. We got, oh, how about this one? This one looks like fun. Can we work it backwards in our brain? How about that angle? Angle T. Do we know its intercepted arc? We sure do. It's half of 86, which is 43. So fun. Okay, this triangle is solved. This is 43. This is 63, this whole part. Do we have a quadrilateral in here? Actually, it's a pentagon. 1, 2, 3, 4, 5. So it's not a quadrilateral. Do we know? I don't know what else we know. Lisbeth is tired. I think I'm gonna call it a night. Okay. Be good, you guys. If you got further than I did, awesome work. I'm sure I can continue, but it's past my bedtime. So be good, you guys. Keep learning, keep trying. Bye.